So we are going to be learning to apply simultaneous equations. So if you can't remember, a simultaneous equation is where we have two lines. So I'll draw a Cartesian plane on here before we continue. And I've got one line. If it's not parallel, at some point it's going to cross and share a point. That point is what we will be finding with you looking at simultaneous equations. When we go on to other graphs and quadratics with linear, there could be more than one point of intersect. So be mindful of that. So there are three possible outcomes when we're talking about linear. There is unique solutions, lines intersect at a point. There is a infinitely many solutions. So that means we've got two lines. I'll start off with my first line, and that's saying I've got one linear line here, and then I'll draw another linear line over the top. So it is exactly the same line. It's just written differently and looks different. But if we simplify them, they'll be identical, which means every point is shared. And then there is the next one that we have no solutions. That means I've got one line here, and that's going this way, and I've got another line going here, and they are parallel to each other. So that means they will never meet. So explain why the simultaneous equations 3x plus 4y equals 8 and 6x plus 8y equals 20 have no solutions. So remember what we said before. When we have two lines that have no solutions, it means that they are parallel. So the gradient is the same. So because it's asking us to explain why there are no solutions, we need to look at the gradient. So for me here, straight away, I'm just going to look at the first equation and get it in y equals mx plus c form. So that would be 3x plus 4y is equal to 8. I will take 3x away. That will give me 4y is equal to negative 3x plus 8. And then I will divide everything by 4 and have negative 3 over 4x plus 8 over 4. I'm not worrying about simplifying because it's about the gradient here. Then if I look at the next one, I've got 6x plus 8y is equal to 20. I will take 6x to the other side. 8y is equal to negative 6x plus 20. And then I divide everything by 8. Okay, so straight away here, it says negative 6x over 8. So that is equivalent to negative 3 over 4. So they are parallel as they have the same gradient. Therefore, they have no solution. So just make sure that you're justifying and providing the evidence. Okay, next question. The system of equations 5x plus 2y equals 10 and 4x plus 4y equals 18 is given. Express both equations in the form of y equals mx plus c. So the first thing I'm going to be doing here is I'll look at this first one. I'm going to get x to the other side, so that will turn into 2y is equal to negative 5x plus 10, and then I will divide everything by 2. So negative 5 over 2x plus 10 over 2 is 5. with this next equation, I will take 10x to the other side, so that will give me 4x is equal to negative 10x plus 18. I will then divide everything by 4, y equals negative 10x over 4 plus 18 over 4. So now it's asking us to show that the equation represents parallel lines and conclude that the systems have no solution. So we can see the gradient is the same. So the gradient, one is negative 5, and second gradient is also, if I divide both of them by 2, it will also be negative 5 over 2. They both have different y-intercepts, so they have the same gradient and different y-intercepts, therefore has no solution. So providing as many facts as possible. Okay, we'll be looking at parameters. A parameter is a variable that represents an infinite set of solutions for a system of equations. So when we are doing a question like this, the first thing I want to think of is we need to be thinking about what does this mean as parameters? Because we know that every point is the same. So that's why we are wanting to have a t-value or another value, just so we can use it for every single coordinate point. So the first thing I'm going to do is I'm just going to let y equals t. I'm going to substitute that into my equation. So that gives me x plus 2t equals 4. And then on my second equation, it gives me 2x plus 4t is equal to 8. So the next thing I'm going to be doing is simplifying and by getting x by itself. So in this case here, if I want to get x by itself, then I'm just going to take away 2t. So x is equal to negative 2t plus 4. I'm just going to stick with this part here. I don't need to worry about the other equation because we know that they're identical. Now, that means I'll be writing my equation as when x is negative 2t plus 4, y equals t. It helps me be able to see every solution to be able to write it. Last question we'll do is show that the simultaneous equation 7x minus 3y equals 14 and 14x minus 6y equals 28 have infinitely many solutions and express using parameters. So to show, I'm just going to line that up. So I can show here that if I times both sides by the same amount, so 2, they are going to be the same. Therefore, I can state that the gradient is the same and the y-intercept is the same. If I'm wanting to express with a parameter, then I'm just going to substitute t in as y. So I'm just going to pick 7x, take away 3, t equals 14. I'm going to get x by itself. So that means I'll go 7x is equal to 3t plus 14. I'll divide everything by 7. So x will be 3 over 7t plus 2. And t will equal y. So I'll erase that part and change it because I wrote it down wrong. I should be saying y is equal to t. So that will give me every single point on my line.